In Python, processes, threads, and coroutines are mechanisms to achieve concurrency, enabling programs to handle multiple tasks seemingly at the same time. Each has its unique characteristics, use cases, and performance implications. In this video, we will have a comprehensive comparison to help you understand their differences and when to use each. A process is an independent program that is executed with its own memory space. A thread is a unit of execution within a process. Multiple threads within the same process share the same memory space. A coroutine is a function that can suspend and resume its execution, allowing for cooperative multitasking within a single thread. Now let's compare their behavior in memory sharing. Each process has its own memory space. In comparison, threads share the same memory, but there are risks of race conditions and deadlocks. As to coroutines, they share the same memory because they run in the same thread, and the risk of race conditions and deadlocks is minimal. The comparison of parallelism and concurrency can be a bit more complex. Processes achieve true parallelism on multi-core machines. However, threads do not achieve true parallelism due to the global interpreter lock restricting execution to one thread at a time. Similarly, coroutines do not achieve true parallelism because they are run in the same thread. Nonetheless, threads and coroutines can achieve concurrency by waiting for multiple I/O-bound tasks at the same time, and each task takes turns to run. As to overhead, processes have the highest overhead because creating a new process involves duplicating the memory space, and communication between processes is heavy. In comparison, threads have a lower overhead than processes since they share the memory space of their parent process, and coroutines have an even lower overhead than threads because they are run in a single thread, thus avoiding the overhead of thread creation. Finally, let's compare their respective use cases. Processes are suitable for CPU-bound tasks like data processing, AI training, image rendering, etc. Threads are more suitable for low-volume I/O-bound tasks that wait on external resources like file systems or networks. And coroutines are suitable for high-concurrency, high-volume I/O-bound tasks due to their minimal overhead. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content. We will have some coding examples for multiprocessing, multithreading, and async await in the coming videos.